Alright, 7th grade, welcome back to your video for section 10.4 in the book, The Area of Circles. On page 452, the beginning of this section, there's a good exploration on kind of estimating the area of a circle. If you don't have your book with you, you should take a look at it at the beginning of class. It's kind of interesting. If you do have your book with you, I recommend you stop the video and take a look at that. It shouldn't take too long. Also on page 453, there's an interesting kind of diagram of how they get this formula for the area of a circle. I also have a cool video that shows it kind of in a more animated way, which I can show you when I get back from Big Sur. But it's a very interesting picture of how you get that pi r squared formula. So the area of a circle equals pi r squared. Now, a couple days ago, you watched a video about the circumference of a circle, which was, let's see, circumference, which equals 2 times pi times r. Notice both of these formulas have a 2 and a pi and an r in them, but the placement of the 2 and the pi and the r are very important because these are going to come up with totally different numbers, unless the rare case where the radius is equal to 2. You'll get the exact answer. But that's not really important. What's important is that these are different formulas. They look very similar. I recommend that you make flashcards for all of the formulas in this chapter until you have them perfectly memorized. They're not too difficult. You'll probably only need to make about 5 or 6 flashcards, but really important that you know those formulas. So let's get on with the lesson here for area of circles. Basically, we have, for the area of a circle, we need to know there's actually just 2 missing pieces of information, the area and the radius. So if we know one of those pieces of information, we'll be able to find out the other one. If you remember, pi is a constant, so although it looks kind of like a variable, it's actually a Greek letter. It does represent an actual number. We use an approximation of 3.14. Sometimes we use the approximation 22 over 7, and I'll explain when we use 22 over 7 and when we should use 3.14. And as I stated earlier, some people just leave it as pi and don't even do the multiplication with it. Okay, so let's get to some examples. If we look at page 454, let's take a look at number 1. It says we have a circle with a radius of 10 inches. So we have a radius of 10 inches, and we need to find the area of this circle. Okay, so again, the formula, which I recommend you write down every single time just so you remember it, is area equals pi r squared. So we are going to use 3.14 for pi, and we are going to plug in 10 for the radius, because that's what's the given information in this problem, and we're going to square it. Now, when the order of operations tells us do not multiply the 3.14 times the 10, first we have to deal with this exponent, so that happens first. The exponent only sees what's directly next to it. So what's directly next to it in this case is this parentheses. Okay, and so what that tells the 2 is that, hey, whatever's in that parentheses, I need to square it. Okay, so what's going to happen first is we have this a is going to equal 3.14 times 10 squared, which is going to be 100. Now this is a very simple calculation. Move the decimal over twice, so we have 314. Going back to figure out what the units were, it's inches. Since we're talking about area, we're asking ourselves how many squares can we fit into this circle? So it's 314 inches squared. So how many square inch squares can we fit into this circle? 314 square inches. Okay. When you get to number 2, of this assignment. It says the radius equals 7 millimeters. Okay, again, the formula, we'll probably be writing it down several times today and tomorrow. We're given the radius again, so we have A equals, I'm going to use 22 over 7. Okay, and I'm doing that on purpose, not just to switch it around, but there's definitely a reason for it. And we're going to use 7 millimeters as the radius, because it's given. So for those of you who haven't realized why I'm using 22 over 7 this time, it's because the radius is divisible by 7. Not only is it divisible by 7, it is 7. So what we do is we have 22 over 7, and we have 7 squared, which is 49. But what we could also just do is write 7 times 7, right? So by just writing the 7 twice, that shows that we're squaring it. Okay, so instead of doing 49, just change it to 7 over 1 and put 2 of them, because that's what the squared means. I'm erasing that because I'm going to put them in blue to show you that that's where that comes from. The reason instead of me not multiplying and putting 49 is it's so simple now just to cross out the red and the blue 7, leaving us with only the red 22 and the blue 7 there. So we have A equals 22 times 7. I don't really know what that is. 140 plus 14, so 154. Going back to the units, it's millimeters. If I look way up there, millimeters. And again, it's how many squares can we fit in, so it's 154 square millimeters. So you use 22 over 7 when you get a radius that's divisible by 7. I would use 3.14 in most other cases. So that'll cover pretty much 1 through 8. Notice in numbers like 5, you're given the diameter. Well, unlike the circumference formula, where you can use 2 pi r or pi times d, the radius, there's no d here. It's just strictly, or sorry, the area formula, there's no d, so we're using r. So if we're given d, we know that the radius is half of that. So if you're given d, cut it in half. If given d, cut it in half. That would give you the r. My favorite part of this section is probably down towards the bottom of page 455. You got numbers 19 through 24. All you're doing is just using the area formulas of different shapes and subtracting them and adding them. I'll give you a basic hint. I'll give you the idea for number 22, and that could probably get you going for the rest of them if you don't already know it. So for number 22, what we have here, I'll probably mess it up when I draw it, but we have this circle. That's a square. We have a square, and then a circle is inscribed inside it. Oh, that's not horrible, not horrible. And then there's the shaded region. So these are all shaded here. Let's just pretend that's perfectly shaded. And we're asked to figure out what the area of the shaded region is. And we are given some information here. We're given that this is 14. Well, it's a square. And so the reason we know it's a square is because the radius is the same for a circle all the way around. And so if it's inscribed perfectly, then that radius must be the same in all those places there. We can actually figure out the radius. So these problems are set up so that you can figure out all the parts that you need. The main idea here is that to find the area of the shaded region, you basically have this square. So you need the area of a square. You need to figure that out. And then imagine that this white part is just someone took scissors and cut a circle out of the square. And when you cut something out, what you're doing is you're subtracting it. So you need to find the area of that circle and subtract it. And that's going to equal the area of the shaded region. Most of you can probably take a look at that and figure out what the radius of the circle is. But the area of the square, you're going to need that side squared formula. So then you'll plug in the s there, which in this case would be 14, minus the formula for area of a circle, and that's going to equal the area of the shaded. I'll just use sh now. So the s is 14. We're going to square that. The pi is, well, I'm going to use 22 over 7, and I'll show you that in a moment why I did that. And then the radius is half of the diameter, which was 14, right? Because we have 7 and 7, and that added together would be 14. So the radius squared would be, again, 7 over 1 times 7 over 1. And we do all that, and we're going to get the area of the shaded. Since I've gone this far, I might as well finish. 14 times 14, I don't know what that is. Let's see. I guess I'll have to do some quick calculation here. 14 times 14, let's see, 140, 28, 56. So I think it's 196. So we'll write 196 minus, and these 7's go away, leaving us with the 22 times 7, which we did earlier. I'm trying to remember what that was, 140, 154? Is that right? If I'm wrong, just write a comment in there. 22 times 7, just double checking. 140, 14, 154. I think I'm good there. And so that's going to equal 42. And again, it's a shaded region, so it is area. We are given units, centimeters, so 42 square centimeters. All right, so that should give you enough to work on the assignment for area of a circle tomorrow. Let's see if I can figure out how to turn this off now.